Hello, welcome to another one of my video log recording sessions where I talk about genetic algorithms. Today I'm not going to be showing anything in particular, but rather I'm going to talk about what I should do in order to move forward from here and on. Well, today mainly I am going to talk about the way I used to measure or assess how the evolution algorithm and parent selection schemes performed. Yeah. So, well, so far I have only been measuring the overall performance by averaging out the top 30 entities, but I have to admit that I was wrong, or to be more exact, to be more specific, I wasn't exactly averaging out the top 30 entities. I was rather averaging out the top 30 summed utility scores that I got as a result of each generation of evolution. What I got in the entities dictionary, and in this dictionary the keys would be the summed utility values and the items in it, or values to that key. Values assigned to that key would be the entities, but the way I calculated did not take into account how many entities there were to each key. And I think now would be a good idea to consider that. And this happened because, well, in the background, let's just try running this, all of it. And this dawned on me today because, not because, I shouldn't, as I was trying to study the distribution of entities at the end of the evolution of, did it finish already? I don't think so. At the end of, for example, 3,000 generations. And when I got that code to work, I found out that there were sometimes multiple entities that had that were at the very top. Not the perfect score. In this case, with 20 items, that would be 710, but like real high scores, but multiple entities. So when I averaged it out, I wasn't accounting for those, and these scores wouldn't be weighted, which is a problem. That in itself is a problem, because then what could be called entities with in quotes good performance would just be neglected. How do I change this to no? Okay. This is what should I do? Yeah, distribution. Yeah. So I need to take that into account, don't I? So let's have a look at this. Oh, well, in this case it's not actually going to work. Maybe this one. Fitcal. Yeah, this should work. Let's run this. So yeah, as I was trying to illustrate the distribution of the results, I found out that there are multiple entities that were good with there were multiple entities with very high scores, and this fact wasn't being considered when assessing certain ways of evolving, or certain ways of selecting parents, or certain ways of when altering the mutation rate or whatever. So from this day forward, I would need to establish a robust way to do that, a way to also consider the number or numbers of entities that have numbers of entities at each summed utility value. And also, if I were to average anything out, I would need to reconfigure or come up with another equation or method to do that. Yeah. And then actually assess the entire situation to decide whether I need to come up with better parent selection schemes, for example. I don't think that the score that I was calculating and using is 100% useless. It will have its own use, but it wasn't thorough enough, let's just say. So that's what I want to address. This is the issue that I want to address. So after this, it should be like that, and oops. Distribution. Oops. Yep, that's actually right. Like that. What? Runtime. One weird thing is that I know, print something like this. That's not gonna run, is it? So I'm going to run everything again. and hopefully it stops here. So any code after this doesn't get executed. So in this video I'm just going to demonstrate what I did. Why is this doing that? This should be like this. Yep. And hopefully we'll see what I mean. What is the parent selection scheme? This is the favoring highs, I think. Do I have PLT? No, I don't. Import matplotlib as PLT. Is this it? I wonder. I'm just going to have to anything. Hold that up. Did it work? Yeah, it worked. So let's have a look at the entities dictionary that I got after the evolution. Not this one, because this one just ignores how many entities there were to each key. Yeah, so this is it. So entities count equals a new dictionary, and then for item in dict entity dictionary count item equals entity dict item length. That works. And then copy the code here. That's not what I want. I know that for sure. Anyway, so I copied the wrong one, but it doesn't matter. PLT plot that, and oh yeah, let me just show what dictionary that I just got. So this is what I got. So we have here that we have one entity at 705, 3 at 700, 2 at 690, but this is going to be hard to see. So let's have this do that. What was it? We take a list. And then keys, do that. And then here we put values. So hopefully my horrendous programming skill isn't what was it? Oh yeah. I did that wrong, didn't I? I imported wrong. See, I knew I was wrong. There we go. There we go. That's what it looks like. But this is again horrible. So I'm just gonna change it to scatter plot, this is it. So here, if I were to get any sort of meaningful metric out of this, I would have to do something like calculate the average of all of these with how many entities there are. That also taken into account, and calculate the average and then plot that out, graph it. I could also calculate the average of top 30, like this one, this one, this one, this one, count from the top and then calculate that. But if there were more, if the population was to be big, for example, in this case, how many are there? Come on. What did I do? Oh, sorry. No, it's values. Yeah, sorry about that. That's 689. So that is to be expected because the initial population was 500 and it was allowed to be 1.4 times bigger than that, around 1.4 times bigger. So that's expected. So top 30 of 689 is what? 4%. Okay, sure, but if the population was to be any bigger, like 1,000, that'd be 3%, or 2,000, that'd be 1.5%, etc. So of course that score is going to be the average of top 30 summed utility values will be inflated, of course, but well, it's not accurately shown. I don't actually know if it will be inflated, but it's not accurately shown, so I have to backtrack myself and then do all of that and make sure that what I've said in past videos are true, or to what extent they're true, and correct myself. So maybe take these into account to get the average of top 10% of the entire population, and also maybe get a box plot, compute the quartiles or the percentiles, etc. So and figure out how much skewed any distribution is at the end of each evolution after n number of generations. Yeah, that kind of thing. So yeah, that's what I will have to do. Hopefully I won't have to make the same number of videos, but it will be a long journey. So I have 12 videos, is it? Yeah, 12. I don't know, I think I have more. I have 13 maybe? I don't know. But anyway, hopefully I can get this done in 5 to 8 videos. So that's about it. Why is it doing that? I don't know. So distribution and new ways of assessing the evolution or evolution techniques and methods. That's the key point of today's video log. So thanks for watching. See you next time. Bye.